Tunneling. Let's start with gateway-to-gateway tunneling. We have static IPv6 and IPv4 tunnel, that's also called 6 and 4, and we have static GRE tunnel. And then we have a 6 to 4 tunnel, which is automatic. We have an IPv6 rapid deployment, 6RD tunnel, we have DS Lite, and we have Lisp. This is all gateway-to-gateway tunneling. Let's have a look at IPv6 and IPv4 tunneling, which is also called 6 and 4. This is a static tunnel that has to be configured statically. This is not an automatic tunnel. The tunnel ends both have static IPv4 addresses and are most commonly on routers. The IPv6 packets that are sent to the router are then encapsulated in IPv4, which is called tunneling, and sent to the tunnel's end, the other router on the right side, and then they drop out as IPv6 packets in the destination network. This enables IPv6 connectivity over an IPv4 only network like the internet, if you don't have any IPv6 upstream connectivity. Another option is a GRE tunnel that's also available for IPv4. The GRE is generic routing encapsulation. It is also a static tunnel that needs to be configured on both ends. Both tunnel ends, same as with the first one, have IPv4 addresses, and on top of the tunnel you configure IPv6 addresses. The IPv6 packets are then encapsulated in GRE packets, which is IP Protocol 47. Have a look at the drawing. You have IPv6 payload on the left, then you have a router, and then you have an IPv4 only network, let's call it the internet, and you have another router with another IPv6 network. And between the two routers and over the IPv4 only network, we have a GRE tunnel. The IPv6 payload, this is the IPv6 packet, you're trying to access some website maybe. This one is sent to the router. The router attaches a GRE header and an IPv4 header like usual. Then the packet is sent to the router B. The IPv4 header is removed, the GRE header is removed, and the IPv6 payload is placed on the cable and is reachable by the destination. The first automatic tunnel version is 6 to 4. This offers access to the public internet. It's an automatic tunnel that does not have to be configured, and it also cannot be configured, and there are public 6 to 4 relay servers available. There are a couple of risks associated with this type of tunneling. There is no support. It can lead to security issues, man-in-the-middle, traffic logging, and so on, because it is public relay servers and you don't know which one is used. So you don't know if it's a hacker, if it's a provider. You send your traffic to just anyone. The operator is unknown. The performance is not guaranteed. It might be good, it might be bad, because you never know what type of access this public relay server has. Maybe it has only 10 megabits, maybe it has 10 gig, nobody knows. And suboptimal routing is not only possible, it's probable, because you don't know where the relay server is. You might send your traffic from the US to Europe just to be encapsulated to IPv6 and then sent back to the US. Doesn't make sense. Let's have a look how this type of tunnel works. The first figure on top, we have IPv6 networks on the left, on the top, and on the bottom. And in the middle, we have an IPv4 only network, maybe the internet. Networks using 6 to 4 are always addressed from the prefix 2002::/16. The next two parts are comprised of the IPv4 address that is just not displayed in decimal notation, but in hexadecimal. You can see on the left that 192.0.2.1 is translated into C000201. The network on the right has a different prefix. It also starts with 2002 and is then comprised of the public IPv4 address of the 6 to 4 host. Routing between these domains is done via IPv4. In the second figure, you can see that the network on the left is addressed from an IPv6 range starting with 2002 and then followed by the public IPv4 address of the gateway. On the right, it's 1111 and the IPv6 network is different. The clients are all addressed out of these networks related to the IPv4 address. Another option is 6RD, IPv6 Rapid Deployment, is mainly used by providers. It is defined in RFC 5569 and loosely based on 624. It enables ISPs to deploy IPv6 quickly without the need for full IPv6 connectivity in their backbone. You only need IPv6 on the CE routers, the routers that are closest to the customer, and you don't need it in the whole backbone. The prefix using 6RD is addressed from the provider upstream prefix. You can see the two customer edge routers on the left. They both have two different networks, and it might seem similar to 624 because there's a prefix of 2001 DB8. In case you remember, it's documentation prefix just for documentation purposes in this image. And then the last part is the IPv4 address of the CE router. So the CE router can have a public address. It can also have a private address. We don't care. 6RD enables the client to have IPv6 in its network using the provider prefix and the IPv4 address of the CE router. And these packets are encapsulated into IPv4 and sent over the IPv4 ISP network to the 6RD relay server, which uses Anycast, and then sent off to the internet. And the internet host will reply to the 6RD relay server. It is then again sent over IPv4 because the 6RD relay server knows what the IPv4 destination is based on the IPv6 address where the IPv4 address is integrated. It sends the traffic back via IPv4 to the CE, and the CE forwards it as IPv6. The next type is host to gateway tunneling. This is for networks that don't have IPv6 connectivity but have hosts which need IPv6 connectivity. There are three main types: Teredo, ISATAP, and Tunnel Broker. Let's start with Teredo. This was developed by Microsoft and is defined in RFC 4380. It is implemented since Windows XP and Windows Server 2008. Clients are always addressed from prefix 2001::/32. In this case, with Teredo, the IPv6 packets are encapsulated into UDP, so there is full net support, not a problem. The Teredo server used to be run by Microsoft, and if you have a client starting from Windows XP or Windows Server 2008, then this client would start an automatic tunnel to this Teredo server, which has a fixed IP address that is known to the operating system, and this tunnel is within UDP, traversing the local IPv4 LAN, the router, and also the IPv4 internet, and is then only sent out to the IPv6 internet from Microsoft server. But as of now, these Teredo servers have been disabled by Microsoft, so this protocol is not in use anymore. The other option is ISATAP, which means Intra-Site Automatic Tunnel Addressing Protocol. It is host-to-router communication like Teredo, and IPv6 packets are encapsulated in IPv4. There is no support for multicast, and like in the previous example, the IPv6 packets from the host are encapsulated in IPv4, sent to the ISATAP router, and then broken out to the internet, which is IPv6 enabled. Let's have a look how that works. To generate an IPv6 address, first the ISATAP client needs to generate a link local address from its own IPv4 address. Second, the ISATAP client sends a router solicitation to its upstream ISATAP router. This ISATAP router can be found either via DNS lookup of isatap.yourdomain, or it can be statically configured. And these packets are encapsulated in IPv4, so it sends an IPv4 packet through your whole IPv4 network to the router, and inside this packet there is a router solicitation. The ISATAP server then sends back a router advertisement to the IPv4 address of the client, which it knows because it just received the packet. The client can then, based on this router advertisement, like in a real IPv6 network, generate an IPv6 address because it knows the prefix and it knows what else the router supplied. Starting from there, we have an IPv6 public address, we have an own ISATAP router and a gateway, and we can send all of the traffic to this router encapsulated in IPv4. The problem is this can lead to a bottleneck because all traffic is sent through this router. No matter how many you have, how many internet connections, all traffic is always going through this one router. The third option, Tunnel Broker, is not really for production use. It is just for trying IPv6 at home if you don't have any IPv6 connectivity using your ISP. There are two main providers. One is tunnelbroker.net, which is run by Hurricane Electric, and the other one is 6access. They have different tunneling mechanisms available, so they will punch a hole through most of the firewalls, should be fine. And a tunnel from the client to the Tunnel Broker server is established over the existing IPv4 network. So you have your laptop in your current network, there is a server at 6access, your client can access this server and establish a tunnel, and on top of this tunnel, IPv6 can be exchanged. Installation is very simple, there are clients for all major operating systems, and you don't need anything special. You can just try IPv6. Check out 6access and Hurricane Electric if you like. In case you want to tunnel IPv6 over IPv6, it's just the same like IPv4 over IPv4 now. You use a GRE tunnel. Both tunnel ends have IPv6 addresses, and on top of the tunnel you also have configured IPv6 addresses, and optionally, if you like, you can secure the whole thing with IPsec. Same thing like in IPv4. Have a look at the example. On the left, you have IPv6 payload, send it to your router. The router encapsulates it with a GRE header and an IPv6 header, sends it over the tunnel. It arrives at router B, is decapsulated, and then sent to the destination network. Same thing like we use with VPNs right now. If you want to tunnel IPv4 over IPv6, maybe in 5 years, if the internet is IPv6 only, you still have IPv4, then you can also use a GRE tunnel, which is still static, always has to be configured statically. In this case, the tunnel ends are IPv6, and on top of the tunnel, you have IPv4 addresses. And again, you can secure the whole thing with IPsec if you like. The GRE tunnel is really versatile. You can run multi-protocol on top of it. So no matter what the basis is, if it's IPv4 or IPv6, on top of the tunnel, you can run both. In this example, you have IPv4 network on the left with payload, sending it to the router. The router encapsulates it with a GRE header and the IPv6 header, sends it over the tunnel, and the destination router decapsulates it again, sending it to the IPv4 only network. It's really easy. So IPv4 over 6, 6 over 6, 6 over 4 with GRE is all the same.